Hello everyone, today we will take a look at the working principle of the KD9300 series music chip and how to use it. The 9300 series music chip is a relatively widely used and earlier type of music chip, such as tinkling music doorbells, birthday cards, fateful buzzers, and engineering work. Vehicles such as sprinklers outside will have this kind of music chip on them. Now there are more manufacturers producing this kind of chip, so the naming of this model will be somewhat different. So this KD9300 only represents one series. Mainly, its peripheral packaging form is the same. How to use it method? The peripheral circuit is the same and its internal structure and working principle are basically similar. First, let's take a look at its working principle. Then this is the internal block diagram of this music chip. It mainly consists of several parts. The first is the oscillation circuit, which controls the frequency of the clock through an external resistor. These components provide the clock, so the oscillation resistor. Some music chips have been integrated internally, and there is no external LED. Therefore, the oscillation frequency is fixed. The fixed oscillation frequency is generally around 100 kHz. Then there are also music chips whose resistance is lead out through the pad. By changing the different resistance values, the speed at which the music chip outputs music will be controlled. So the tone sounder is actually a note sounder. It emits different notes through the data in the entry. What the inclusion sounder generates is an inclusion signal. In fact, the inclusion signal determines the timbre. This is the music chip. The timbre of this series of music chips is basically the same. The driving circuit is generated by the sound generator, which is used to drive external speakers. Some music chips do not have this amplification part inside, so external triodes need to be added to drive the speakers. It is an external preamplifier, so it can drive the speaker directly without connecting a triode tube. So the rhythm sounder is actually a beat sounder. It will generate about 8 beats to control the rhythm of the music. So the entry is actually a read-only memory. Its capacity is relatively large. Small ones are generally about 32 bytes and larger ones, maybe 128 bytes, 512 bytes, are relatively large. So what about this music chip? In fact, the music is not recorded in it, but is controlled by the code stored in the memory to control each component to play the music. If so, its cost will be lower and its structure will be relatively simple. This kind of music chip only stores one piece of music. It is triggered by this trigger signal to play the music. Every time it is triggered, the complete music will be played again. Then the stop signal will also be stored in this memory. When the music is played, it will output a stop signal to control these parts to stop the music output. Only when it is triggered again, the music will be played in. So let's take a look at how it is used. The way it is used is this method. This is the middle part of the external circuit of the music chip. The circuit board of the music chip is the circuit board of the music chip. This part of the chip is usually packaged around the branches. This is also a common and relatively low-cost packaging form. There are 4 large pads at the bottom. The pad on the left is the positive electrode of the power supply. Its supply voltage range is generally between 3 to 4.5 or so. Then the second pad is the music chip that triggers the 9300C. Its triggering is triggered by the positive pole, which is a high-level trigger. There are also some music chips that are triggered by a low level. The third pad is the music output used to drive the speaker. It has actually passed after the triode is amplified. The speaker is used for power amplification through this triode. The fourth pad is the negative electrode of the power supply. There are 4 pads in the middle. So these 4 pads are actually connected to the inside of the chip. This is the audio output of the chip. The NPN type triode is generally used to connect this triode. So the reason why we spend 4 pads here is because the packaging shape of this triode is different and its pin ordering is different. For example, the commonly used NPN triode is like 9013850. These more commonly used NPN triodes face the pin surface. The leftmost part of the model is usually the transmitter level E, and the middle one is the G level B. The rightmost part is the C electrode level. Most of the triodes are ordered in this way. There are also some triodes, such as some imported models. The ordering of the 3 pins may be somewhat different. For example, ECB or counting E from this side. The different arrangements of CB are all different. So the 4 pads are mainly used to facilitate the soldering of these 3-stage tubes in different arrangements. At the same time, what is being driven is a speaker. If the driving power is relatively small, it is like the kind of pressed ceramic plate or passive wind in the music Heka. As for a device with a relatively small sound, it actually does not need this triode for amplification. So just connect a pressure chain ceramic piece directly to this place. The sound required is not particularly loud. And let's say that this triode is because the amplification power of a single triode is limited. If the power is higher, then you can connect a higher power audio amplification behind the music output. For example, if the alarm sound is like a horn speaker, a relatively high power one may require a relatively high power part of the power amplification. Then the work of this chip is started by this button. Turn off the trigger. Every time it is triggered, it will complete the playback of the music. If the trigger end is always connected, then the internal music will play in a loop and will not stop after playing it once. So this kind of chip, its trigger R end will be more sensitive. Sometimes, due to the electromagnetic interference from the outside, it may cause false triggering of this chip. For example, when turning on a light or turning on an inductive load such as a motor, it may cause false triggering of this chip. So when it is actually used, a small capacity capacitor is connected between the trigger terminal and the negative electrode, which is usually a ceramic capacitor. It can be relatively small, generally between 0.1 microfarad and 1 microfarad. In this way, it can effectively avoid false triggering caused by external electromagnetic interference. So this is just a basic application of a music chip. As long as these external components can make it make sound, the same is true for its extended use. On this basis, for example, I can connect a piezoelectric ceramic piece to the trigger end, which is a wind inscription device, which is the sheet-shaped wind inscription device from Hickory. So this kind of wind inscription device will make a sound if you turn on the power. It is reversible. When it is subjected to external mechanical vibration, it will produce a very small sound. Weak voltage can be used to trigger this music chip, which can be used as a voice-activated doorbell or voice-activated alarm. Of course, in this way, because its output voltage due to vibration will be relatively small. If there is no amplification, its sensitivity will be relatively low. If you want a higher sensitivity, you can use that. For example, the microphone of the main body is amplified to trigger the trigger end of the music chip, which can be used as the starting end of a voice-controlled music chip. This is the use of our music chip. Let's demonstrate this through a physical object. This is the 9300 series music chip. The film is like the middle part. This is the package of the flower branch. The following is the chip that makes up its music. From the back, you can actually see its internal structure. This is a triode. It is a 9013 model triode NPN. Then this is the battery, a 3.7 volt lithium battery. This is the power switch, this is the speaker, then this terminal, the second sound corner is its trigger terminal. Now we turn on the power switch, because it is not triggered now, so it will not make a sound. So now we short circuit the trigger terminal and the positive terminal. It is triggered by the high battery, so this one on the left is its positive terminal. This is a ding-dong doorbell that will play 3 ding-dong sounds every time it is triggered. Suppose I connect the trigger terminal directly to the positive pole, and it will play the internally stored music in a loop. If this music chip is initiated by a short contact, it will play in a loop. If it is triggered once, it will play it once. Then there is also a part of it. This kind of music chip, when the short contact terminal and the positive electrode are connected, it will be powered on, that is, the moment the switch is turned on, it will automatically trigger once and then stop. This is related to the internal structure of the music chip and the model, so each model is different. At the same time, like this 930, the 0 series of music chips can represent a relatively large category, such as other commonly used chips such as the KD9561 series of 4-beat alarms. Its packaging structure is different from the peripheral packaging, but its use method is also similar. It requires an external triode and also has a trigger terminal, but that the chip has 4 alarm sounds and it will have an additional sound source selection. Different combinations of positive and negative electrodes will output different music or alarm sounds. So there are many types of music chips now, including this series. The internal storage is one piece of music, and there are those that store multiple pieces of music, such as 12 pieces of music. Well, it can use this trigger terminal, which means that every time it is triggered, it will play a piece of music in a loop. There is also a certain piece of music that can be selected through an external trigger terminal. Then there are also the following, for example, with this code, it can also be recorded. Then it can also be recorded. Now, there may be some MP3 decoders. Chips are also used more often and the cost is relatively low now. So in the future, we will successively explain the usage of different types of music chips and the internal structural principles. Okay, this video ends here. Thank you for watching.